Hi, welcome back to Music Chemistry. This is Empirical Molecular Formula lesson number 2. Remember that empirical formulas are the simplest forms of formulas using the simplest whole number ratio. Molecular formulas show the number of atoms within a molecule that are often not in simplest whole number ratio. And it's also important to remember that 1% of something is equal to 1 gram. All right, let's look at the first problem. What is the molecular formula of a compound who has a molar mass of 264.18 grams per mole and an empirical formula of C2H F? So what we need to know, first of all, is what is the molar mass of C2HF? Okay, we have 2 carbons at 12.01. We have 1 hydrogen at 1.01. These are all in grams per mole, by the way. And then we have 1 fluorine at 18.99 grams per mole. All right, so when we do all the math, add it all up together, we get this to be 44.03 grams per mole. All right, now we know the molar mass of the compound, which is 264.18. So what we're going to do is we're going to take 264.18 divided by the empirical formula, molar mass, which is 44.03, and then we're going to get approximately 6. Okay, so what we're going to do is we're going to take the empirical formula, which was C2H and F. We're going to multiply each of these by 6. See that? This is going to give us the molecular formula C12H6F6. Pretty easy, huh? It's not that bad. It really isn't that hard. All right, so now let's look at the next problem. What is the empirical formula of a substance that is made up of 18.7% lithium, 16.3% carbon, and 65% oxygen? Remember, it's important to remember that 1% is equal to 1 gram. So let's go ahead and figure this out. So we go 18.7 grams of Li times 1 mole of Li divided by 6.94 grams of Li. Where'd that come from? Periodic table, of course. So our lithium is going to equal 2.69 moles. All right, let's look at the carbon. So we go 16.3 grams of carbon times 1 mole of carbon divided by 12.01 grams of carbon. And that is going to equal, let's see here, right at about, looks like 1.35, but let me double check. And it's going to be 1.35, right. So go 1.35 mole of carbon. Last but not least, we have to do the oxygen. And let's see here. So we have 65 grams of oxygen. And we're going to multiply that by 1 mole of oxygen divided by 16.00 grams of oxygen. Notice that we're not using diatomic oxygen. And that's going to give me, let's see, 65 divided by 16. 4. Ooh, this is looking pretty good. 4.0 mole of oxygen. Now what we're going to do is we're going to take and set this up. So we have lithium, carbon, and oxygen. So we're going to go with, see, lithium was 2.69 divided by the smallest unit, which would be 1.35. Carbon's going to be 1.35 divided by that 1.35 again because it's the smallest of the three. Then oxygen is going to be 4.0 divided by 1.35. So this is going to give me 1 for this one right here. 2.69 divided by 1.35. It's going to give me 2. It's going to be 1.99, which is 2. All right. So we're going to make that a 2 right there. Oops. Okay, and then we're going to look at this 4 here. So 4 divided by 1.35. It's going to give me 2.96, which is 3, right? So this is going to give me the formula Li2CO3. And that's it for this particular lesson. You guys be snarly. And we'll see you back here at Moosine Chemistry.